Hi everyone, and welcome to the third Mario webinar in Companion Robotics. So the webinar today will describe the semantic technologies behind the Mario platform. These technologies are important to enable Mario to model and interpret the world around it, supporting a flexible interaction with the end users. So to talk about these technologies and these semantic techniques, we have the speaker today, Valentina Presutti, who is a prominent and well-known researcher in the area of semantic technologies from the Italian National Research Council, CNR. So Valentina is a researcher and a team coordinator at CNR, and she is also a leader, a technical leader within the Mario project. So we should have now a presentation of about 30 to 40 minutes. Then we'll have 20 minutes for questions and answers. So Valentina, thanks for joining us today and for giving this talk. I'm looking forward to the talk.
Okay, thank you very much, Andre, for the presentation. So I will talk about what more or less what we are doing in Mario as a laboratory and also in collaboration with the other partners. I will focus mainly on the work my team is doing. And in particular, I will mention many times probably the word frame, because I want to discuss how we are using frames in our developments within Mario. And of course, what I'm going to present, it's a teamwork, the result of a teamwork. So you can see here a picture of our very nice group. Some of them are actually missing, but anyway, this is the Semantic Technology Laboratory team between Rome and Catania in Italy. So I will focus on mainly two topics. The first is Framester. As I will tell you in a few seconds, Framester is a resource that we've been building during the Mario project development, but it's a linked open data resource which implements frame semantics and which provides a lot of linked and rich information and data that can be reused by the community beyond the project of Mario and beyond also this domain. And then I will focus more on how Mario is a robotic use case for building a frame-based software architecture. So I will tell you how we are using this notion of frames in the architecture development of Mario. Okay, so let's start with giving you the intuition of what a frame is. So a frame is, we can also call it a situation type, so a type of situation, and also intuitively, this is what it is. It's what we usually recognize. It's the way we recognize and interpret the world around us and what happens, the events and all the data that we have, that we acquire normally. And in more rigorously and in a computational environment, a frame can be represented as a relation, an n-ary relation. And from a representation point of view, it can be represented as, for example, this example, prepare coffee, which is an example of a type of situation, of a frame, can be represented, prepare coffee, as a relation with to a binary relation, for example. So, or in general, a relation with a fixed arity. Or we can make it a little bit more flexible, more sophisticated in terms of representation, and have a multigrade arity. So the arity is not fixed. So it depends on what are the participants that are involved in this situation. Or we can use a neo-Davidsonian representation of relations, which includes among the argument also the events, the event itself, expressed by the relation. And especially in the domain of computational linguistics or natural language processing, I mean in linguistics, we have additional, so the representation of frames has evolved by including other elements. For example, the roles, which are semantic roles, which are relations between the event itself and each of the participants. And they have, of course, a semantic qualification. So, for example, agent, theme, time, location, and so on. And finally, we can also add the types that the arguments playing some role can have in the context of a certain occurrence of a frame. So, and how can we detect a frame, or in general, where do we find them? So, in this slide, you can see that there are two lists. So, on one end, we can see that we can actually detect frames in many different types of sources. For example, linguistic structures in text, or databases and other formats, or even from sensor data, for example, and on pixels, coordinates, so we can recognize and detect types of situations or frame. And we can, in order to do that, we can use various elements that are involved in these sources. So, for example, words, or senses and classes and properties, entities, or images and videos, and so on. So here, what I show is a sort of summary of tools and graphical representation of their outputs, of the state of the art of the tool that allow us to extract frames, in particular from natural language. So the first one on the top left of the picture is a semaphore, and from a text it identifies what are the frames that are involved, that can be recognized in the text. So in this case, what we have is that we recognize an occurrence of a frame prepare in this sentence, Valentina prepared the barley coffee. Boxer instead is a tool that transforms text into discourse representation structure, which is a specific subset of first order logic, and give us this box like representation of and it's a formal representation, logical representation of the text, the same sentence. And then we have Fred in different versions here, which is a tool that we developed in our laboratory, which also provides a formal representation of text, but it is based on also on so it does additional processing in order to enrich this formal representation and to make it result in a knowledge graph, let's say, ready to use for the semantic web. So what we do with Framester, that I'm going to show you in a few seconds, is to sort of change a little bit, shift or push a little bit further the idea of using the notion of frames. Consider that I'm using either frames or types of situation as a synonym in this talk, to push this idea of using frames and actually the frame semantics as the main means for interpreting data. So this means that each of the elements that are expressed, for example, in a text, and hence transformed, as you can see in this picture, in a formal representation, are interpreted through some as a projection of some frames. So which means that, for example, a role, which is a binary relation typically, is interpreted as a binary projection of some frame. The same apply to individuals, which are interpreted as unary projection of frames. So in other words, just to give you the intuition, the point is that we consider that everything can be interpreted in terms of some frames or their combination. And so this is the basis of our development, and in a sense the principle of our approach, the approach that we are developing within Mario, and that we have been inspired by for producing this resource. So Framester, as I said, is a resource which makes some semantic assumptions. So one is using the neo-Davidsonian representation of events. Then the other is what I just said. So we consider that all predicates are either frames or projections of them. So we consider that everything can be interpreted in terms of frames. And then another semantic assumption is that we represent frames in terms of an ontology and a theory that is called description and situation, which I briefly describe with some examples to give you the intuition. So the description and situation is an ontology pattern, to simplify the idea, which allows to represent for example, plans and their executions. So the point is that you can represent at the same level, in the same level of discourse, and hence in the domain, both the description of a description, hence, for example, a plan, a security protocol, a norm, a diagnosis, and so on, and its corresponding occurrences, like, for example, the execution of a plan, an application of a security protocol to a specific threat event, or a case which is recognizable and can be contextualized by a norm, which is its corresponding description, a patient state against a diagnosis, and so on. So in the case of frames, so a frame is a description, and all its occurrences that we can recognize are situations. So this is the way we represent them in this resource. But what is Framester? So these are the semantic assumptions that we use in order to represent the data within this resource. So we use frames and their projections, and a neo-Davidsonian representation of events, and description situations as a vocabulary for representing frames and their occurrences. More into the data, what we did is to take, so this picture shows which were the main data sets available in the linked data cloud related to the lexical domain, and not only, because you can see there is also the DBP ontology, schema.org, and so on. So not many of them were there and linked to the other. So what we have done initially is to add more RDF datasets linked in this domain. So the different colors, there is a magenta here, each dataset has a color, and it means, in a sense, it gives you an indication of what is either the domain that it covers. So what we did is that we took existing datasets, and for some of them, we made a work of transformation and translation into RDF datasets. So we analyzed the data sets, their conceptual model, and then we transformed them into linked data. And also, when you see an orange dotted line, arrow, it means we also produced semi-automatically new links between that data sets. After having more data sets available in RDF, what we did is that we produced, as I said, semi-automatically, a lot of cross-links between them. And we added also this model which realizes, let me say, strong frame semantics in terms of what I said, so that represent everything in terms of frames and their projections. So everything started from the alignment between FrameNet and WordNet and WordNet SynSet, and then from there we have propagated and created new alignments. And we reached more than 40 million triples in this resource that is now available to the community for which can use it in order to as a background knowledge that span from lexical knowledge to word knowledge and so on. And as you can see from the picture, is a sort of a small advertisement. We are going to add the paraphrases very soon. We already have the dataset transformed in LOD. We have to work on how to align it in terms of designing the conceptual model for the alignment. So this means that we have everything aligned and linked. So we have this cross-linked and this representation in terms of frames. And what we did, so this means, let me go back just 1 second. This means that all the entities that are in all these data sets are linked to some frames by a relation that tells this is either a frame or a projection of this frame, and which in turn can be interpreted also in terms of an evocation function. So if I have a certain entity, I can say that that entity evokes a certain frame. So based on this intuition and the theory, we have experimented with this resource for the task of word frame disambiguation, which in a sense is frame detection. And we have built in collaboration with Paris 13, the University of Paris 13, we have built a frame detector based on which uses a word sense disambiguation algorithm, and we rely on either Babelfy or UKB for this task. And then we directly use the linking structure of Framester in order to reach and to extract the frames that are related, that are evoked and identified in a certain sentence. So we have experimented with the frame corpus, and what you see in this slide are the results of these experiments. So first we have used the FrameNet annotated corpus, and you can see on the, and we have done this both with UKB and Babelfy. On the left, you can see the tools that we have used, and profile F, B, D, T are referred to Framester, which are sort of different subsets of Framester. Framester has been built in order to have different profiles, and the profiles are, there is a profile which is sort of minimizes certain alignments, and then basically our intention was to test also the noise that you can get when you include additional annotations. So as you can see from the result, Framester can reach the best F-score with one of its profile. It's not the best in precision, but it can reach the best recall with another profile. But anyway, it reaches the best result with the profile B, with both Babel 5 UKB. It doesn't beat Semaphore, but here actually there is a bias because Semaphore is trained on this specific corpus. So actually, I think the results, in fact, it's really, really high. So we decided also for this reason to test on another independent corpus. And in this case, as you can see, we actually don't beat Semaphore in terms of precision, but the recall is certainly much higher. So in terms of F-score, Framester definitely overperform the other tools. So by doing this work, we also had the opportunity to conduct error analysis, and actually this is something that goes ahead even now. And this gave us the possibility to discover errors in the individual data sets and the individual cross bilateral, let's say, alignments. So, and as we can do this, so we can represent, according to our theory and intuition, anything in terms of frame or the projections. This can be also explained in terms of by saying that by claiming that frames actually naturally support knowledge reconciliation, regardless the logical, conceptual, or syntactic representation of knowledge sources. This is what we mean is that frames are everywhere, and so we can interpret and analyze everything, which can be data from any type of sources in terms of these semantic structures. This is why we have decided to apply this intuition and this theory to the within the Mario project. And I'm just telling very quickly a few words about the project. I think you all know it, but I mean, I actually cannot be sure. So it's a European H2020 project, which has the goal of addressing, or at least contribute to address one of the problems that our society must prepare to address, which is health concerns of older persons, because on one end we have an increase of life expectancies, on the other end this goes along with some of the typical problems that people over 60 years old have. For example, depression and various forms of dementia. And the point is that there are studies that tell us that we can actually slow down the decline due to dementia. But the problem is that in order to do this, you have to be mentally and physically and socially active. But when a person is diagnosed with dementia, usually he or she feel embarrassed, and so it tends to isolate it tends towards self-isolation, which means that if you're lonely, it's very unlikely that you're going to be socially, mentally, and physically active. So this is the strong motivation behind the Mario project, and the vision is, of course, to contribute to decrease loneliness and increase autonomy by increasing autonomy. So why a robot? Because a robot for people who suffer with this disease is actually probably one of the best form, because a machine is not bothered if you, for example, ask it the same question again and again, like in this picture. You can see these people have usually the first symptoms are about memory, so the capability to have short-term memories. So maybe a question can be repeated over time, over and over again, and the robot certainly cannot be bothered and annoyed from this behavior. And also because a robot has as compared to, for example, a tablet or a mobile phone, it can actually move and be proactive. So like in this case, that he can drive and show where a place is, for example, if the person doesn't remember. So some of the functionalities that Mario features are, for example, allow to connect with other people by using Skype and chats, applications such as real-time chats and instant calls, and also to help with the reporting to the carers, and in particular with the medical staff. Also, for example, help the people with dementia to remember, for example, where they put certain objects, and to entertain them, like, for example, reading stories and books or news, but also to help them to remember when it's time, for example, to take a pill, or if there is any other urgent or important commitment to address. So what we did is to develop an architecture in order to support this robot. So the point of Mario here is that it has an architecture that, if you look at this picture, is not that different from other robotics architecture. But the real difference is that throughout the architecture, the notion of frame is a recurrent notion, and also it's reflected in the implementation of the core behaviors, the core components, as I will tell you in the next 5 minutes. Other two aspects that I would like to mention are the fact that the architecture is open, in terms of the fact that there's no constraint on a specific programming language or platform. So all the functionalities of Mario can be used through REST services. And in fact, we actually have a number of apps and components which are developed in very many different programming languages. And the other concept is the one of affordance, that I will spend few words while talking about the behavioral arbitration. In fact, the next thing I want to tell you something about is the behavioral arbitration, which has to do with the the management that Mario has to do of its functional and behavioral capabilities. So and this allow it to be autonomous. So which means that Mario has to be able to move, to operate in a dynamic environment, to interact with the user, but also doing this autonomously, which means taking decisions according to the observation that it can do of its environment, and avoiding conflicting situations. So being able to judge if among, for example, two possible behaviors, he has to choose because there is either one that has a higher priority, or there is a conflict between the two, and so on. So Mario needs to take decisions according to this context-aware and user-dependent behavior selection and arbitration strategy. So it has to select the most appropriate or relevant behavior and avoid conflicts. So, for example, if a person, the patient, asks Mario to look for the keys because he doesn't remember where he put them, Mario can do this. But, for example, what if he's running out of power? Of course, what happens is that the two situations are conflicting. So Mario cannot search for the keys and concurrently go to the charging station. So the charging is certainly prior than looking for keys, because he could run out of power. Another example is, for example, is that the patient asks for listening to some music, and Mario, of course, can address this request. But, for example, if it's 2 a.m. in the night, he should be able to say, no, this is not the time we can listen to music because we're going to annoy the neighborhoods, for example. So what we implement in our behavioral manager is a mechanism that is based on the concept, on the notion of which is originally from Gibson, of affordances. And the affordances, they are used a lot in user interface design, for example, in ergonomics and so on. So what we do, so an affordance is an opportunity for action. It means that when I perceive an object, I don't perceive it as such in terms of an ontological perspective, but also I perceive it in relation to what I can do or what is the function that is associated to that object. So what we do is that we use affordances in order to describe the functional expectation that we can have when we recognize a certain situation. So here, as you can see, again, the notion of frame comes into the game. And in fact, the overall approach, as you can see here, is that you can see this orange bars, which is situation recognition, which is the core of what we do, both if we have to decide what behavior to choose, or, for example, if we have to interpret some natural language requests. And the affordances are implemented as weighted functions, weighted relations between situation types or frames and possible behaviors that Mario is able to expose. The same applies to natural language understanding. Actually, the natural language understanding part is a specific case of situation detection. So we need to have an interaction that has to be very natural because, for example, these people sometimes they cannot learn. When we, for example, use Siri or Google Now, or even if we just use the Google interface for searching, you can notice that we sort of adapt and develop a method for maximize the result that we obtain from these tools. With these people affected by dementia, this is not a possible approach because they are going to forget. They understand very well if you explain them rules, but maybe the day after they have just forgot everything. So the interaction has to be very, very natural. And the types of examples of dialogue can be that the person doesn't know where to find food. So Mario should have a common knowledge, such as knowing that the food is usually in the kitchen, or help them identifying a word that they cannot remember. Like in this example, Mario, I need to send, what's the word? And then Mario should be able to say, maybe it's a letter, and help the person. Or show a place, or ask about recent events, personal events, so help with personal memories. So all these dialogues actually require background knowledge and advanced reasoning capabilities, and some of them are far beyond what it is possible with today, what we have today. And what we are doing is, with Framester, for example, is working on developing techniques for creating richer and evolving background knowledge and diversified and sophisticated reasoning capabilities. So we really have the tip of the iceberg with respect to what we need, but we can do something if we, for example, focus on specific aspects. So I want to show you what we want to be able to do, and in a sense give you the intuition of what mixture of techniques we are using to achieve this result. So imagine that we have this sentence coming from a patient, which is, Mario, I'm hungry, where should I go? So, for example, using some inductive techniques, we can detect that the words hungry and where are related to the concepts of food and place, for example. And also the verbs go and andare in Italian. So here you have both the English and the Italian because Mario supports both languages. Then we should know, we can actually derive still with some inductive techniques that food is related, is a close concept, is a concept close to the concept of kitchen. So they can be close in a sense, in a distributional sense. So for example, we're using distributional techniques to find out exactly this kind of relations. But then we know, for example, by using ontologies and linked data, that kitchen is a place. And we can use also abduction and say, okay, look, maybe if we have this distributional information that food and kitchen are close to each other, we can try to make a semantic a distributional assumption and say this is maybe a relation that we can qualify as usually located in. And then if we know this, we can use deduction, for example, associate. So we have recognized a situation, and then we can associate this type of situation to a behavioral function, like, okay, when you recognize this kind of situation, tell the person that the food is in the kitchen. Or by using observation and induction, maybe we realize that the person wants to actually that the robot show where the kitchen is. So this is a very hard cycle. And if you consider that you may want to do this in many different domains, so the question can be the question or the request in general can go on any type of domain. And again, I go back to this overall picture in order to stress that besides doing an observation of the environment, the physical environment, or a processing of a natural language input, what we have to do is to recognize the frame or the frames we are facing in order to take decision and make some action, which can be either a behavior like a motor behavior or activate some functionality or simply retrieve the information that we have to give as an answer to a question, for example, or just reply and feedback with some natural language based dialogue. So this is the previous picture enriched with the framester and the ontologies that we have and this interpretation based on frame semantics. And to conclude, so what I've tried to explain to you is that we develop our research and our solution based on the idea and the theory that frames are at the basis of our reasoning and interpretation capabilities. We have built a linked data resource which implements this theory and which contains lexical and word knowledge. We use frames, we are using and experimenting with frames as the common interpretation reasoning structure within the Mario platform, both for the behavioral arbitration and the natural language understanding. And as I said, many of these dialogue types that I've shown you require much richer background knowledge and reasoning capabilities, and this is the direction of research we are going towards. So thank you very much for listening to me, and I'm happy to get questions now.
Thanks, Valentina. Very, very nice talk. I enjoyed it a lot. So we have some questions here. I'm copying some of these questions to your chat box just to facilitate your reading as well. So
okay, thanks.
The first question is, you have created a very complex and rich model, 40 million triples, as you described. Which of these link sets are more or are most useful for addressing the more immediate requirements of Mario?
Well, okay, thanks for the question. it's not straightforward to to answer, because what we are using, so for example, it's let me make you a concrete example. So two of the applications that are under development and trial within Mario are the CGA application, which is something that that the medical staff uses. So the CGA, for who doesn't know, it's an assessment, it's a questionnaire basically that the medical staff does to the patients in order to assess their cognitive status. So Mario is supposed, and actually is under trial for doing this questionnaire and replacing, let's say, the physicians. And the other ones is helping the people to with their personal memories. So, for example, by showing them pictures and asking them to tag these pictures or to answer some questions based according to the knowledge that Mario already has. And of course, this is personal knowledge, but it can be combined with also linked data knowledge. For example, if there are certain behavior in the picture or places, so we can get information there. So as to go to your question, in these two cases, so one, for example, the CGA is we are using a lot paraphrases, for example. This is why, and so this means we pass through the recognition of the words and then try to identify through paraphrases to interpret the answers of the patient to the questions. In terms of the memory, what we are using, what we're going to use is the sentiment related knowledge. Because we will try, so what the memory app tries to do, it's not only to assess if the person, for example, remembers something, but also to understand so what are the types of emotions that certain picture evokes. So we will try to store also this information. And the links between personal knowledge and DBpedia, for example, are also very important. And finally, but this is something that it's, let's say, a step ahead, the frames themselves are also something we need. So the links to the more complex frames when you need to do into deep analysis of text. For example, if you have complex sentences and you are not able to match easily with a shallow analysis of the text. So you try, so with having the frames and their roles is also important to interpret, to attempt at least an interpretation.
Thanks. I have another question. I'm just copying again. So apart from the link association, how do you operate inferences over Framester? I think the question is related to the intrinsic conceptual model behind Framester, and how can you make benefit of existing reasoning techniques, maybe beyond taxonomical reasoning? Yeah, I think the question is more in this direction.
Okay, so in terms of, because so the point is that reasoning over Framester, okay, for sure, what we do is to use the alignments, which are the result of some reasoning procedures. Because when you do the alignments, or for example, the creation of data and links to the others, these are usually they are the result of some reasoning. And the reasoning is not to be considered only in terms of, for example, description logic-based reasoning. Like so, what we apply are different techniques in order to obtain and produce data that enrich Framester and that can link to other. For the example that I did for the food and kitchen thing, it's actually a true thing. It's taken from my work we are doing for Mario and for enriching the background knowledge. So we are using, in that case, distributional semantics, and we are trying to combine the result of a geometrical representation, a distributional representation of concepts with some formal semantic concepts by making some assumption and say, okay, look, if you have two concepts that are closed, then we make an assumption of what kind of relation this can be. And this is a long story because in that case, we are focusing, for example, on objects, physical objects and locations. And we want to discover, let's say, what these relations and produce them. So the reasoning, so I'm not sure I understand the question. I'm not sure if I'm answering, but the reasoning that you can do by using Framester is, I mean, of course, it's a linked data resource, and its formal model is expressed in terms of OWL, but I see more the resource as already enriched with the result of reasoning procedures, which can be of very different types.
Yes, I think
of course you can reason also over it by using our capability, but now I don't have a specific example, let's say, for but you can of course make inferences with the standard OWL based or RDF based reasoners, for example, or simply by writing Sparkle rules, of course.
Perfect. Good. Another question from the natural language perspective. You gave a semantic role labeling example to interpreting the user input. Is your natural language interaction scenario based on a semantic role labeling approach?
It depends. At the moment, within Mario, we didn't use deep parsing, and but for example, we do have also this option. Our tool for this purpose is Fred, and it actually does this, does frame detection and the semantic role labeling. So I can actually, if you want to, you can post, I don't know if there is any way to give the link to Fred, but so the person who asked this question can just can go there and have a look with some example. So in principle, yes, although it's also true that roles, are not always more than roles. The thing that it's sometimes tricky is to is about the types of the arguments, so of the entities that fill those roles. Yeah, but yes, I mean, for example, with Fred, we do perform semantic role labeling.
Okay, perfect. Thanks. Another question: have you thought about dealing with figurative language, for example, rhetorical figures such as metaphor, irony, sarcasm, using frames?
The answer is yes. We thought about that many times, and actually, we are also in my, in collaboration between people in my team and other. There is an ongoing work with some good results with respect to sarcasm, to irony. Is it not yet published? I think, or
it was a challenge.
I think we are going to participate in a challenge. Sorry, it's not me directly working on that, but in my group and also some people that we collaborate with. There is something going on with this, and we actually had some interesting results applying frames for. And see what you can gain in identifying ironies. irony. Of course, this is a hard task, but very, very interesting and but challenging task. Within the scope of Mario, I guess we won't be able to apply and experiment with this, but this doesn't mean we are not going beyond, and we can have maybe an evolution of Mario in the future that will also be able to detect irony and maybe also produce some ironic sentences.
Thanks. Another question, how do the affordances work in more complicated situations? For example, Mario has to call a doctor because of a medical emergency, but it's almost out of charge. So I think the question goes in the direction of the representation of affordances. If you can deal, how do you formalize these affordances? And if you can express complex affordances scenarios or learn or induce complex affordances scenarios.
Okay. To be honest, we didn't deal so far with the very complex composition of affordances, but we have very clear the challenge, and we have a model that we want to try, and we will. So what is our plan is to test the model on probably data that are produced, automatically, because actually the situations that you get with the robot and the person, we are running controlled experiments, so it's very hard to have it. This is just because of the reality of the situation. However, my answer is that there you need to have a policy, and any policy you can have, you represent it in terms of affordances. So if you are interested in how we model them, we actually had a paper in the workshop on ontology, design and patterns last year, and I'm happy to share it. Actually, I'm not sure it's the proceedings are published yet, but I can share the paper. No problem. So as regard to the model. On the other hand, so to the ontological model, and basically we use situations, description and situations for modeling the situation, and we have a model for affordance. Then what happens is that you typically have an evolution on the value of the affordances. As I said, the affordance is a relation which has a weight between a situation and a behavior. And they can be either negative or positive, and they change based on different criteria, okay? And these criteria include, for example, what happened in the short term, previous short term, or general assumptions of priority. In a situation like the one described in the question, clearly this is a very strange thing. I mean, you cannot do. Charging the robot is something that must have priority over anything else, because the robot is going to run out of power and it's not going to be able to do anything. So this is a very special example. But in general, if you put, for example, the emergency of calling a doctor or doing something else, which can be critical anyway, but maybe less critical, in principle, the model should allow to evaluate that calling the doctor is as much higher priority than the other compatible behavior with the situation observed, and then do the right choice, okay? So in principle, then of course there can be situations which are impossible to deal with, like the one, so if the robot is out of power, it cannot call. So either it charges or anyway would fail.
Thanks. We have another question. So how Mario interprets more specific intensity, for example. scenarios. Like imagine that you have a patient saying, Mario, I'm very hungry, where can I get food? Instead of Mario, I'm hungry, where can I get food? So this type of fine semantic interpretation, for example, interpreting this intensifiers from adverbs, for example, or valence shifting. Are you coping with this phenomenon?
Well, actually, no, we are not coping with this because in the project, what we do is mainly develop for the natural language processing part and understanding. But the speech recognition is something we delegated to an off-the-shelf component. However, it's a very good one because it's Nuance Dragon, which is, I think, the same that Siri uses or something like that. So it's really state of the art. But when we get the text from Dragon, we don't have this kind of differentiation. So I don't know, maybe there is a way to configure Dragon, the speech recognizer. I'm not really an expert on speech recognition, but this would be more something on that side, to recognize the modulation, the tone, how strong is the intensity, if the people is yelling or not, if the person is yelling. We don't know this because what we got is a text. So text is, in a sense, very plain with respect to the tone.
But in case you get, for example, an adverb in the text that expresses this intensity, can you interpret that in your model, or is something
okay, sorry, I thought the intensity of the tone of the voice, but if you have very or without very, well, yes, we have a sentiment analysis component, so in principle we could, but we didn't implement this feature. I mean, we didn't implement this kind of differentiation in the interpretation. But this can be done by leveraging with the so what, for example, Fred, the same tool that I posted before, we do identify and differentiate the type of adjective and adverbs that we meet. So we have a special ontology of adjectives there. So in principle, we could leverage on this. So the data are there. So if we want to do it, we have this in the representation. So in principle, and I have to say this is a good idea. We didn't think about that, but we didn't do that. But the data for doing it, actually, I wouldn't say straightforward, but it's not a big deal because we already have what we need in the formalization of the text.
Okay, so this was the last question. Would you like to add anything, Valentina, or otherwise I think?
Just that I'm happy to receive also questions by email if there. So I would say all the people would first thank all of them to attend, and of course feel free to email me if you want to have references or discuss. I'm happy to do this offline. And thank you very much for having me at the webinar.
Thanks a lot, Valentina. This was a very interesting talk, very nice talk, very interesting work. Yes, I think our webinar today is over. So thank you all for attending and see you next month. Bye now.
Okay, bye.